jump right into it. So today's webinar, as I mentioned earlier, is sponsored by Puppet. And I just want to jump back to the first screen if we can. Well, hopefully you all saw the title, maybe we don't. But how DevOps practices and orchestration help drive change with confidence. And it should, that's a mouthful, but I think it's going to be a great webinar. Let me introduce you to our panel today. If we go to our next slide, we have two great folks from Puppet. We have Michael Olson, who's from Product Marketing at Puppet, and we have Ryan Coleman from Product Management, and I think Ryan's going to be really diving deep here onto this, and it should be enjoyable. Let me just quickly go over our agenda for the next hour or so. If we could go to the next slide. So today's agenda is why DevOps, and hopefully that's not too hard a question for many of you out here. Some of the key practices we're going to look at, where to start, how orchestration fits in, and this is an important thing. I hear from people all the time, they hear the term orchestration kicked around in DevOps an awful lot, but not everyone is 100% sure of what that means. And then, as I said earlier, Ryan, I believe, is going to kick in here with a real hands-on demo, and we've saved some time for QA, so it should be a great webinar. So if that's out of the way, I think I'm going to hand things over to Michael, and he'll be driving the bus here for the next half hour or so. Michael, you there?
Great. Thanks so much, Alan. I'm here, and thank you, everyone, for making time out of your day to join us. We're excited to dig in and talk about some of the stuff that Alan helped tee up. So I think just to kick things off, we've reached the point where every company at its core is a software company. Really, as more organizations are discovering ways that technology can be a pretty key competitive differentiator for the business. And one of the challenges that most of the organizations that we talk to face is really the need to move faster without compromising the reliability and stability of their systems. And I think a lot of IT teams these days are under pressure to increase the speed and the frequency with which they get new technology in the hands of their customers and users. But at the same time, are being asked to kind of maintain legacy infrastructure and applications, also strive to maintain the high availability and reliability of those systems that they're responsible for managing. And so a lot of the companies that we work with are at some stage of their own DevOps journey, where for most of them, it's really looking to do just that. It's looking to either align the business development and operations teams around the customer value that their work delivers, or they're just looking to bring agile practices into IT to help improve the speed of deployment as well as the stability of the technology that they're managing. So I think it's no surprise that, according to some research from a source that we'll talk about here in the next couple minutes, more than 3/4 of IT teams that we talk to these days are on some stage of their own DevOps journey. So with this, I'd like to pass things back to Alan quickly. I know we wanted to get the perspectives of folks who are on the call here about kind of, where you're at in your own DevOps journey as well. Alan, do we have a poll question that we can ask the group? Alan, not sure if you were on mute there.
Oh, I'm sorry. Yes, guys, I'm sorry. I'm talking. Jules, can we load up our first poll question? Okay, this hopefully is an easy one for most of you to answer, if not to actually do. Does your organization have an active or planned DevOps initiative? Yes, no, or you're not sure? Just real quickly, if you can give us an answer, give us an idea of where everyone is out there, and if we can have your answer in 5, 4, 3, 2, 1. And survey says, well, as I think I probably would suspect, 75% of you either have active or planned DevOps initiatives, 15% no, and then 9% don't know. Well, this is the right webinar for you then. Michael, what do you think of those answers?
My honest take here is I don't know if we could have planned that any better, given the fact that it looks like the folks who responded to this poll question were probably the same types of folks who were responding to our own DevOps survey that we put out last year. Pretty consistent results there, so that's cool to see. And great to see that so many folks on the call are thinking about this already. So here at Puppet, we recently, in middle last year, published our annual State of DevOps report. And I know for many of you who are avid and loyal readers of DevOps.com like I am, you may already be familiar with it. If you haven't seen it, definitely encourage you to visit our site, puppet.com, give it a read. Last year, we surveyed more than 9,000 IT professionals really to understand the key characteristics of high-performing IT teams. And I think that the findings of last year's study really give us some concrete numbers to, underscore the value of adopting DevOps practices. So, one of the more common obstacles that we hear time and time again around, moving to more of a DevOps way of working is resistance to change. And over the last 4 years, our data has pretty consistently shown that high-performing IT teams are more agile. Specifically, they deploy code 30 times more frequently than their lower-performing peers, and they also deploy 200 times faster on average than their lower-performing peers. And we also found that even with these faster and more frequent deployments, companies that are implementing DevOps practices are also substantially more reliable as well. That these high-performing IT teams have 60 times fewer failures on average, and they're able to restore service about 168 times faster in the event of a failure. And what we also found last year is that strong IT performance also provides a real competitive advantage. So within this year's DevOps report findings, we found that companies with high-performing IT orgs are about 1.5 times more likely to exceed their profitability, market share, and productivity goals than their peers. And we also found that there's a strong correlation between IT performance as a result of implementing some of the practices that we'll talk about and overall organizational performance. Specifically, we found a correlation with companies implementing DevOps practices seeing 50% higher growth as measured by market capitalization. So here at Puppet, we definitely don't just buy the notion that DevOps is a single tool that you can just go buy or implement. It's really more about people and process, with technology as kind of a key enabler of that process change. So I'd like to spend a couple minutes here to talk about some of the cultural shifts and practices and technology that our customers are focused on as they adopt really more of a DevOps way of working. And from a people perspective, most of the customers that Ryan and I talk to that are on some stage of their DevOps journey are looking to move their organizations from one of, say, low trust and siloed teams and poor visibility and lack of alignment to one with, a high trust culture where teams work cross-functionally with fast feedback and insight, and where really all groups are aligned around shared goals, around the value that they're trying to deliver to the business through software and through technology. And to do that, I think, requires a culture of continuous improvement where there's a willingness to adapt and change, not only from the management level, but also from the grassroots level up. I think it also requires a new way of kind of thinking about process and tools to support some of those cultural shifts as well. So for example, most of our customers who are pretty far along in their DevOps journey are employing continuous delivery practices across their organization, from the dev side all the way through into operations as well. And in last year's State of DevOps report, we found that there are really kind of 4 key practices that serve as the foundation for a continuous delivery workflow. One of them is just the notion of automation, right? It's automating the manual work that extends from, infrastructure configuration to testing, as well as deployment of applications and infrastructure. A second kind of key practice of continuous delivery that we found is having a trunk-based continuous integration workflow to enable teams to integrate code into a shared repository on a frequent basis. We also found that, as another enabler, is for application developers and operations teams to be able to employ a common set of version control practices so that teams can, easily collaborate and iterate and roll back when necessary. And then lastly, and while it's not on the slide here, we also found that peer review is a pretty key enabler of delivering better software faster, as opposed to forcing all changes through a monolithic change approval board, for example. And when companies implement these types of technical practices, we tend to see a strong correlation with benefits like less deployment pain and being able to deploy more frequently, and also being able to change more confidently by experiencing lower change failure rates, for example. So from a technology perspective, we tend to see a blend of tools used to help enable a more DevOps way of working. So, we see things that our customers are using like automated configuration management and deployment tools, as well as version control systems and continuous integration tools, as well as monitoring at both the core infrastructure as well as the application tiers. So you can see a few examples of some of the technologies that comprise kind of the DevOps tool chain as we see it here on the slide. I'd love to pass things back over to Alan and get the perspectives of folks on the call. What types of tools, that as part of a DevOps workflow are you using within your organization today? Alan, can we pose that question to the group?
Yes. Jules, let's throw up our polls question. And Michael, this is a really good question. I mean, one of the things we've seen is an explosion of tools, within the DevOps tool chain. What's interesting is some are sort of native DevOps, if you will, they're new and they were designed around DevOps ways and what have you. Others are old tools that are kind of taking a DevOps, bend, if you will. Anyway, which technologies within the DevOps toolchain has your organization adopted? And you can select more than one. So have you done anything with version control, configuration management, continuous integration, automated deployment, monitoring, all, some? Anyway, let's get your answers. We'll close it out in 5, 4, 3, 2, 1. Survey, please. Version control, far and away the winner here. I would think config management would be higher, Michael. I'm a little surprised with that. Continuous integration. Well, go ahead.
I think it's good to see that folks who are on the call are kind of thinking about the role that these tools play as part of adopting more DevOps-like practices. Definitely as I mentioned earlier, we're big believers that there is no kind of one universal DevOps technology, and DevOps is really more about process and culture with tooling that helps kind of support and enable that. But looks like definitely some opportunity as well from folks who are on the call. So thanks for making time to share kind of your current state.
Absolutely. Let's move along. While we are monitoring, I think is a high growth area around DevOps in the years to come. But we'll go back here to Michael's presentation.
Great. Thank you, Alan. So, I think as companies begin to think about implementing some of these processes that we've talked about, getting the supporting tooling in place, what we often hear is that infrastructure as code ends up being kind of a key enabler and really serves as the foundation from which you can build more of a DevOps way of working. So when you treat your infrastructure as code, it becomes possible to implement really a lot of the practices that we've talked about and apply agile practices to managing infrastructure. So as an example, when you treat infrastructure configurations as flat text files, you can do things like check them into a version control system. And when infrastructure is expressed as human readable code, you can do things like peer review it. It becomes possible, easier to ensure consistency across dev, test, staging, and production environments, and also do things like automated deployments really to help your teams become more agile and your systems more reliable. And I think together these practices enable some of the benefits that we've talked about, things like fast feedback loops, the ability to iterate quickly, better collaboration across dev and ops teams as they begin using a common set of processes and tooling, and then also better visibility into the application and changes that are taking place across the infrastructure. So we tend to see kind of this common set of practices as the key to becoming an agile, lean organization that continuously learns and improves. And I know we've talked a lot about over the course of the last 15 minutes or so, kind of building the business case for DevOps, some of the key practices that underpin it. With that, I would love to turn things over to my friend Ryan here to paint a little bit more of a detailed picture about how some of these technical practices can help overcome resistance to change and really help great companies become better software companies. Ryan, take it away.
Thank you, Michael. Yeah, so this slide resonates with me. I've got a background in systems administration myself, and I manage infrastructure for the core academic team at a large university. And as this source describes in more detail, a lot of the outages we see in production environments are due to unexpected change. And that could be an automated process that's putting out configuration incorrectly, but it could also be drift between machines that are manually configured. You could have one set of machines configured for, in one way, but the other set serving one logical customer configured in another. Those can drift over time, and outages can occur there. So really what I want to get into is some of the technical practices, and then some of the ways you can use tools like Puppet Enterprise to sort of assert change more confidently and execute it to your infrastructure more quickly with our orchestrator, but trying to tie back some of the practices that Michael talked about in terms of infrastructure as code, version control, peer review, and some of these other practices that you can add around some of these DevOps tools to drive change with confidence. So the first thing, and these are sort of more generic lessons that I think apply to any tools in this space, though I'm going to show you a demo in a few moments of Puppet in particular. And really what we've learned from people is this idea of making change directly when you need to make it. And there may be a lot of teams trying to make change to the same infrastructure at the same time, but the whole goal of DevOps here is to collaborate with the people making that change. So if it's a core infrastructure change, you're working with multiple ops teams to make sure a change is clearly defined, it's been approved, and it's being enforced in the window that makes sense for the group. But it could also mean collaborating between a dev group and an ops team. And when you do make those changes, you want to make them on demand. You want the server infrastructure to come back and tell you about the failures as they occur, and that's kind of on. Oh, Michael's got to update GPG. With security, another big aspect of a DevOps tool chain that we won't have time for today. But go ahead into the next slide. So that real-time feedback and visibility is really important. So if you're pushing out a change in real time, you don't want that to just be spooky action at a distance where you're now waiting for your infrastructure to report back on how that change went. So one of the key characteristics is being able to review changes as they're happening, have a sense of whether it's going well, hopefully have a system that's going to help inform you on how the change is going, be able to speed it up or slow down, and have an opportunity to investigate issues during deployment. Another aspect, and this is where I'm going to pause and kind of step back on orchestration for a moment, is I think orchestration, if you go and find the dictionary definition of orchestration and then follow that to Wikipedia as I have, orchestration is very loosely designed as, or defined rather, as a mechanism for coordinating action to achieve a desired result. And in the computing sense, it tends to imply some sort of inherent intelligence that helps you achieve that desired result and helps you sort of assert some kind of behaviors that that tool should respond to. So this is one example of that, and this is, and I think if you break down orchestration, you're looking at how do you orchestrate configuration change, how do you orchestrate the deployment of applications, how do you orchestrate the different tasks you might take on your infrastructure, and then orchestration has more recently been used to talk about container workloads. How do you organize groups of containers into logical application stacks, and then how do you distribute that workload at scale? So this slide in particular is about configuration orchestration. If you've got an application stack that has a database service, a web tier, and a load balancer on hopefully more than one instance of your web tier, you need some sort of orchestration to order how those hosts are configured. They share information with each other, and then how that change is enforced really matters. This is where that inherent intelligence of an orchestration tool comes into play. Because if your database tier fails to apply a schema upgrade or update package versions, you don't want to go downstream and continue to reconfigure your web service with the expectation that that web service is functional and upgraded when it's not. Go ahead to the next slide. Okay, and so with that, I'm going to give you, I'm going to take presenter control here and move over to a live demo. Now this live demo is going to be based on Puppet, and I'm going to try to give you a sense of how this relates to some of those tasks you saw on the other slide, specifically version control, peer review, and so on. But I'm going to start here in our enterprise console. This is just an overview of the infrastructure I'm currently managing with Puppet, and this is giving me an overview of how infrastructure has changed over time, and we're going to come back to this later in the demo. Before I get too much further, I want to make sure we're all on the same page about how Puppet looks at infrastructure. So here I'm logged into one of my Puppet infrastructure servers. and I'm asking it to give me its description of a user account on this machine. And this is my user account on the box, the one I'm logged into. And Puppet's view of the world is all about state. Puppet's not a scripting engine. It's not about taking one action then another. All of that is sort of built into Puppet, the configuration orchestration tool. So instead, Puppet's telling me the state of Ryan as Ryan exists today. And I could also ask it for another user like Michael. And I can see that Michael has similar characteristics. Now, what you usually do with Puppet is take descriptions like this and you combine them with other descriptions that make sense. So you could, for instance, ask Puppet for all the package resources, just to give you another example. So system packages, whether this particular machine is a Linux machine, whether that's Windows, whether that's Mac OS X, AIX, Solaris, Puppet represents everything in the same way. The package name, the version you want, and any other details about that package that you need to manage. And so what you're routinely doing is combining these bits of Puppet code together to represent infrastructure. And I'm going to show you more of those in just a moment. But Puppet is also able to make changes, obviously, to this configuration. And I can demonstrate one interactively here where I'm going to change Michael's shell from bash to sh. And I'm just asking Puppet, it looks like I don't have Michael and password D, so I'm going to have to do that to myself. But you get the idea here. Puppet knows how to go and look to change from bin bash to bin sh. Michael hasn't logged into the infrastructure that I thought he did, so I can't actually change his shell record just yet. But Puppet still does its best to understand what Michael's configuration is coming from our LDAP service. But that's enough of that. I'm going to go back to our control repo here just to give you a sense of the demo today where I'm going to make change directly, and I'm going to show you how we can use an interactive tool to understand how that change is occurring. So to do this, I'm going to use a couple of these modules I've already downloaded from our Puppet Forge. You can think of these as software libraries for infrastructure. Someone's already taken those individual user and package resources and combined them together. In this case, this person's combined them to offer sudoers configuration, or I can describe sudoers like this and have certain users allowed to run commands as sudo, either all commands or specific commands, and I can configure that with Puppet. And then the second thing I'm making change to is SSH configuration and a very similar abstraction layer. I get to interact with configuration settings like this. I can say permit root login. I can change that value as I wish. And someone underneath the layer here is manipulating the individual files, talking to the individual services, and managing individual packages. Again, think of them like infrastructure software libraries. And finally, I have this control repo. So this is sort of the focal point for the change I'm going to be demonstrating to you today. And this is really where you gather together a list of all the Puppet modules, all those infrastructure libraries from the Forge or runs you've written yourself. And this ends up being a description of all the possibilities for my infrastructure. And then I can use this control repo to assert change to this entire code base via version control branches. Now in this case, if you recognize that I'm using GitHub, but one of the core ideas here is that if you're already one of those people using version control via our poll today, or you're looking to investigate version control, you should use what's comfortable for you. We use Git here at Puppet. We recommend Git for anyone who's getting started with new version control systems. But if you're using Perforce or Microsoft version control, all of those kind of have the same idea behind them. Represent your code as text, and then make change to it collaboratively as part of a version control workflow. Speaking of that, I have a Git here on the right side of my screen. This is on my local laptop where I've made a local clone of that orchestration control repository I was just showing you on GitHub. And I've already made a branch called remote management where I'm going to assert a change to my running infrastructure. I've already made this commit just to skip a few steps for the demo. This is just the normal Git workflow of making change to text and then committing it into the version control system. And now I can just show you the results of that change. I'm going to make this a little bigger. And this is one of the core aspects of infrastructure as code, this ability to describe your configuration as text and then use tools like Git to show you exactly what change you're making and have a discussion about the individual change diff. In this case, we have a bit of Puppet code called a profile. This is really just a way of wrapping together some configuration that you're going to assign to individual hosts. And I'm just setting up a group of users allowed to sudo. I then manage individual SSH settings so that I can say you can log in with your password. I'm not going to allow empty passwords. If anyone is in our system without a password, they can't SSH in. And then I also set up that the users I list above are allowed. I could be pulling this from LDAP groups. I could be combining this data however I'd like, but it's easier to show you from a static array of users. And then I also use that list down here, and this change I'm asserting is going from a static list within my pseudo setting to using that array. So I already have that change on my machine, but I don't have it yet on my infrastructure. So the first thing I'm going to do is push that change via this branch to my control repo. Let's talk about what that does. If I go back to my control repo, GitHub will tell me that just less than a minute ago I pushed this branch, and I could start doing a pull request to bring that into the production branch of my infrastructure. Now, this is my version control system. This isn't Puppet itself, but Puppet's connected to this control repository. And anything in the production branch is being enforced on all of my infrastructure. So if I'm not quite sure about this change yet, I want to have a discussion with my team, and ideally I've tried it out on some of my infrastructure first. So I'm not yet going to create a pull request. Instead, I can use this branch in my Puppet server to evaluate a change a little more interactively and locally. So the first thing I'm going to do now that it's available on my GitHub server is I'm going to go back to my command line interface, and I'm going to show you how I make this change live on my Puppet server. I just take that same branch name, and I tell Puppet, go ahead and deploy that environment. You can think of an environment as an isolated workspace for making change. Anyone who's going to be using Puppet, whether in their operations side or dev side, you can create this workspace that's special to you, name it something that's meaningful to you. Maybe you're collaborating with multiple people in this workspace, but it's separate from how the rest of your production your production infrastructure is being worked on. So this is telling Puppet now to go work with my Git server, get the changes that I've described here on the right side, and it's making those changes available live on my Puppet server in this remote management workspace. So once that's available, I can go and run some machines against it, and I kind of need to wait for that to finish. Okay, it ran. There's a bunch of information there that I can inspect into. I'm going to run it one more time just to get a shorter response. And I should be able to go back now to my Enterprise console and begin to tell machines to try this version of the change. To do that, we have these grouping mechanisms. This classification tab. I may need to refresh here since I'm going quick for the demo. Give me a moment. And the first thing I'm going to do is create a group that has that remote environment attached to it, which apparently is not yet available. I go back to my terminal here, says it was complete. I'm looking for this remote management environment to show up on my Puppet server. But it is running in a data center separate from me, so it may take just a moment. There we go. Okay, so back to the demo portion here. I set up remote management, and this is where I'm just going to assign machines to this thing here. So you can think of this as slicing off a bit of my production infrastructure, which is why I have that inheritance. I can go and edit it. Now this isn't doing anything. I'm not assigning any work to it. All I really want to do here is attach one of these machines here. I just have one of these cattle machines available. I happen to know that that one's one that hasn't had these changes, or maybe it has. I might go and add another machine here. I added some earlier. Actually, I can show you a regex for that. So we have all these facts available for understanding if your, for instance, your operating system is Red Hat. It'll show you how many nodes match. And I'm going to say I want machines that match that operating system, but also match the hippo name. Oops, I think I did that wrong. No, I'm adding a caret for no reason, just because I'm getting fancy in this demo. So we can go back here. We can add that swine machine that I wanted to add earlier. I'm going to go ahead and pin the hippo nodes, not to waste your time, just to add a few of the machines that I want to evaluate this test on. So I save this out. I need to now tell the machines what work they need to do. And this is the separation of the infrastructure as code to the individual assignment of work. So if you notice back from this change diff, this whole class of configuration is called profile remote management. And all I'm doing now is saying that any of these machines should get that bit of configuration so that they can evaluate that change, and the rest of my production environment doesn't have to. I did commit that. Now that I do that, I can go back to my command line here, make this full screen, and I can ask Puppet for a list of machines that should match that environment. And it's picking up those 2 hippo machines that I've just added, and now I can interact with them by doing this job run. And this is where I'm telling Puppet to go ahead and enforce this change. But I'm also going to tell it one more thing. I'm going to tell it no op. And this is one of the key aspects of making a change confidently. First, we've isolated our environment. So now the entire production infrastructure isn't getting this change that we're asserting to our group. But we're also telling Puppet to go one step further and simulate the change from these machines as they're configured now to the state I want them in with this new configuration. And as we get these back, we can go and view their reports. Now, in this case, we're getting a summary that nothing's changed on these hosts, so they might have already been added in to this particular configuration. And we can wait for the other to finish as well. While we're doing that, we can go back and add other nodes to this infrastructure, for example. Pick off some of our machines at random. You could also have a predefined canary group that you're flipping into this, and I can continue to run that against the node I just added and continue to iterate until I'm happy with the change. And I can follow these back to our console and view reports. And you can see whatever granularity you care about the infrastructure that's being changed, whether it's unchanged or that you've had failures in the past. And that's just this interactive loop that you can iterate on and continue to push change to until you're happy. So let me show you that real quick. I'm going to open up our text editor. Similarly to version control, you can bring any editor you choose. It doesn't have to be this GitHub's Atom editor that I'm using today. But I'm going in, and you saw this git diff of this change, and I'm just going to go and add Michael's user account to this list of authorized users for SSH. I'm happy with this change already as it's been asserted, so that's just the one change I want to make. And the workflow, you can see as my machines have run here, the workflow is to look at the git diff I have. I can add that file now. I can commit. You usually want to pause and write a more meaningful message here. In this case, I'm going to just say, as an authorized sudoers user. Usually your commit messages are your best opportunity with your team to talk about why did I make this change to the infrastructure, and then later I can go back and have a discussion about whether that change was appropriate if for some reason it wasn't at the time. But the key here is that I can push this commit now to my remote, and so I've added change. I can go back and do that code deploy step to reestablish this change, take this addition of Michael Olson and push it to the fleet, and then I can redo this loop of asserting a change on infrastructure. You can see that was complete. We're going to run this again. This time we're not going to simulate the change. We're going to add this change on all 3 of those hosts and add Michael to the group of hosts. Now the next step that I'm going to skip ahead on while it's running those infrastructures, if you decide that this change is appropriate, that's when you go and you make a pull request and you discuss it with your team. And you can see here's the original commit message that I made, and then this second one that you just saw me interactively add where Michael was added to the list. And you can have a discussion with your team about that pull request. That's one of the core tenets of infrastructure as code. You have the history of changes as you make them, and then as you introduce change to the infrastructure, you can have a line-by-line discussion, if you wish, on the individual change. So you want to usually add more information to that, but you propose this change. This is where you can have a discussion. You can run tests against this code base, and so on. If we flip back, we'll see we had more infrastructure run there. I can merge this pull request. So now we've taken this remote, isolated workspace, and we've combined it into our production working branch. Now this isn't yet live on the Puppet Master. As you can imagine, the command to do that is similar to the command we just did to deploy the Michael change. So now I'm just asking it to redeploy the production environment. And while the Puppet server and our code manager service goes and retrieves this merged pull request and adds it to my Puppet server, I'm going to go back and add that remote profile to my entire infrastructure. Okay, and this is where I assign the entire infrastructure that work. Oops, ran into an issue there. Let me try that again. Might have raced the machine. We can actually just go and do it here. Oh, it's already added. I just need to flip this environment. Okay, so we have our production environment, all nodes, using this remote management class. We've already finished pushing that to production. I can go back and run Puppet job plan now in production. And this is where we can start to see all the instances that are going on. And another idea of this tool is to start telling you the pending change that would apply to all these hosts. This particular build just shows you the hosts. And then as you saw on the slide earlier, if you describe relationships between these hosts, Puppet will run in respect to those relationships. But let's finish out here by running this and show you another feature of running interactively. So now that we have a larger set of runs, I can tell Puppet how slow or how fast to run. Instead of doing onesie twosies, I can start talking about dozens of hosts, and Puppet chose to start running with as many as it could handle at a time, the maximum number. Now, one of the things about this is I have this job identifier, and if you wanted to follow along as part of the team looking at these changes as they get made, I can background this, and I can take a look at that individual job, and you could have a discussion about how that job's going. So that command produced just a summary. I'm making this change. It affects these hosts. Here's the ones that are completed with their individual change reports. Here's the in-progress runs, and here's the upcoming runs. I can go back to my interactive run, and if I see that this change isn't going to plan, I can interrupt this job. It'll continue to finish the configuration in progress. We don't want to leave machines in an ill-configured state, but it won't continue to run on future infrastructure because you're at this point aborting the change. Another way to view that change instead of individual reports is to go in the configuration view here, and you can start viewing by other criteria. You can view by those classes of configurations, you can view by the nodes, or you can view by the individual resources, like you saw me pull up user accounts and packages. And here I can start viewing, in this case, a Windows machine had its service change, and I can go ahead and evaluate that. Okay, so we've stopped that job. I can show you now. I can run that job again, and I can say I only want to run 3 at a time. Maybe I'm more slowly phasing out that change, and Puppet will run on those 3 hosts in order. But that's a gist of interactive change with orchestration. Key points here being my infrastructure is described within the code base here. I can have a discussion in version control about the change in a workspace that's separate from my production workload. I can then interactively try enforcing that change on a subset of my infrastructure using that environment, and then I can phase out that change in production as broadly as I like.
Great.
I think we're ready to take it over to Michael.
Yeah, thanks so much, Ryan. Really appreciate it. Alan, I'd love to take the time that we've got left and see what questions folks on the call have that we can address.
Absolutely, Michael, and thank you. Actually, thank you both, Ryan. I always love a good demo on a webinar. So for me, that and you did it masterfully as well. And I've done demos on webinars, and not everything always works the way you think it's going to work. And you know, but you did a great job with it. And speaking of that, I want to apologize to a bunch of our audience here. It seems because we probably had checkboxes instead of radio buttons or something vice versa, people were not able to select more than one on our tools thing. I almost want to redo it so we can see if it changes, but I don't know if we'll have time to do that. Actually, I think it should have been checkboxes instead of radio is what it was. Okay, but let's get to some real questions. And again, though, I do apologize for that. Okay. Ryan, I don't know if this is a you or a Michael question, but is Puppet Code Deploy a command code from Puppet?
Yes, all the CLI I was showing here on the left side of my screen, those were the Puppet client tools package that you can install either on the Puppet Enterprise infrastructure itself, or you can install on your laptop, on your workstation. On the right side, I was using the standard Git command provided on my Mac.
Got it. Next, and might be English is a second language issue. Is Puppet for an enterprise usage can be free or cost for free? I guess he's trying to ask, is Puppet Enterprise free, I guess, or can be used for free? Is there a free version of it, perhaps? I'm not 100% sure. Would you like to answer that, Michael?
Sure. Yeah, happy to address that question. So Puppet Enterprise is free on up to 10 nodes, 10 different machines or servers that you want to manage and automate, and you can simply go to our website, puppet.com, follow some links to go and sign up, and you can get started right away. If you're looking to kind of roll it out across your infrastructure that spans more than 10 nodes, we do have pretty straightforward pricing that we can walk through, and you're welcome to reach out to anyone on our team anytime, and we can kind of talk through the details there.
Okay, and in real DevOps fashion, we've taken that short feedback loop. We're going to rerun that poll question with checkboxes rather than radio. So and most of you are still here. So if we want to get a good question on this again, which technologies within the DevOps tool chain has your organization adopted, and you can select more than one? Why don't you go ahead and do that? I think I remember what the old answers were, and we'll see if there was a difference. If you can do it quickly, though, I don't want to take away too much from our questions, but 5, 4, 3, 2, 1. All right, Jules, did it change? Wow. You know what? It did change. What do you think, Michael?
Yeah, I think that's interesting. It's first of all, it's great to see that an overwhelming majority, nearly everyone on the call, is using some form of a version control system. That's great to see. Obviously, that's a pretty critical part of the workflow, as you saw from Ryan's demo. And I think it's also encouraging to see that a lot of organizations are kind of on the path toward continuous delivery using a CI tool. A little bit less adoption of automated configuration management and deployment, but still more than half, and that's certainly an opportunity that's near and dear to our hearts here at Puppet. And I think from a monitoring perspective, that's an area where we're seeing more and more interest as teams look to kind of enable those fast feedback loops and be able to iterate more quickly. Monitoring becomes a key enabler of that. So really interesting to see the results, and appreciate folks taking time to kind of share their current state.
Well, enough people commented in questions, and I was glad we were able to get that. I mean, for me, the two big things were actually the two lower ones. Configuration management and monitoring jumped from about 11% and 5% respectively up, to over 50% or thereabout as well. So excellent. And thank you, everyone, for doing that. All right, let's see here. Is Puppet for Enterprise next? Well, that was a big thank you, guys. Okay, how efficient? Ooh, that's a good question. How efficient is Puppet with containers? All right, we could probably do a whole webinar on that. But Michael, you want to take a shot, or?
This is Ryan. I'm going to take a shot at that one.
Go ahead.
containers is interesting with Puppet. I think there's two things I want to call out. One side is the image build side for containers. So in a lot of ways, you wouldn't want to run a Puppet agent to configure an individual container. It doesn't make sense to run that as part of the container. It's kind of breaking the model, and it's not very efficient. So instead, you have that same infrastructure as code base. You want to retain the qualities of peer review in version control. But instead of configuring individual machines, instead you're configuring image inputs to containers. So that's how you would look at it from the Puppet side. Puppet's configuring a host that results in an image that you're then deploying to containers, and you keep that chain of custody so that you know that a container is running from that image, and you can track that image back to change commits in your version control system, much as you saw in my demo. And then the other side of containers is, of course, the operational side of it. And in that respect, what you see from our project Blue Shift that we launched here with 2016.1, we're starting to look at how does Puppet interact with all of the software coming out for interacting with container workloads. So think of Kubernetes, think of Docker Swarm, think of Mesosphere. These software packages care a lot about how to distribute and maintain containers at scale, but there is still this lacking piece of interacting both to deploy those images that you've configured with Puppet, but then also deploying infrastructure that's mixed between database service running on bare metal and application tier running in virtual machines and many other API services running in containers. What we're looking to do is merge those so that you have to use the tools of your choice for, say, container scheduling, but get to link that into how the rest of your infrastructure is managed.
Excellent. Okay. Next question. How does Puppet do an application deployment? Is there a change for continuous deployment? Ryan, Michael?
Yeah, Ryan's going to take that one. So what I didn't have enough time to cover today is making an application deployment with the same tool set as I showed you. You saw me make a change to SSH configuration and sudo configuration, but the mechanics are the same regardless of any change you want to make. And so we have a bit of Puppet code that describes how an application stack is arranged, so your database relating to a middleware tier, relating to a load balancer, and then the mechanics of making that change to version control are the same as what you saw me show, and then the deployment itself happens through that command line experience where you can deploy a change to, say, a dev stack of your infrastructure instead of the whole production fleet, and then roll it out as you like, and all the tools are the same for that. It's just changes the bits of infrastructure you're touching.
Yep. Okay. I don't see another question in our question section. We've got the repo done. You know what, guys? Unless we have another question, if you don't mind, I'd like to ask a few questions, or a question or two, not a few. I wanted to talk about recently Puppet it was a big announcement, as you guys obviously know a Puppet, but our audience may or may not be aware, where Puppet kind of, it's no longer Puppet Labs, it's Puppet, brought in some high-level new execs, but more fundamentally, it seems like the enterprise product has really become much more solid, much more scalable, much more enterprise ready, and not to say that it wasn't enterprise ready before that, but Ryan, I would bet, or maybe Michael, maybe both of you, can you talk to us and our audience a little bit about what some of these sort of enterprise enhancements recently that have come about are, and why people should care? Or did I put you on a spot doing that?
No, that's fine. I'd be happy to talk through it. And I'm actually also going to take this opportunity to, like the poll question, show something that I forgot to hit a checkbox for as part of the answer to this question. So I'm taking back presenter rights here. But before I do that, I want to more directly answer the change from Puppet Inc. to Puppet. So I've been with the company now for coming up on 5 years. I came in at about 60 people, and we're nearing 450 now. And so it's a change that's hit me, pretty personally, to change from Puppet Labs to Puppet, and I think it's just a market or marking a shift from us just being a more mature company. We've always focused on the enterprise software, and we're just now growing into the point where I think you're noticing where we're able to attack a lot more of the surface area a lot more quickly than we were able to at a 60-person company. So this is really our reflection of what scale we're at now and what we're able to do, but we've always been caring about these particular types of problems. But you have noticed, and I think the software I'm about to re-show you here is an example of a lot of the fit and polish we've been able to add in the last year or two. So just to go back, if you didn't notice in my demo, my changes weren't applying because I forgot to check one box during the demo. So I've rerun this no-op job. And one of the things that it's doing is now showing actual pending changes on all of these hosts. So if I pick off this one at the top here, oops, I need to actually click on the link. One of the other things about the enterprise product that's changed recently is all of this different event reporting. So I'm going through to show you the pending change on these individual hosts, and I can show you that in different granularities. It tells us what the state is and what it wasn't. And now I'm going to go just real quick and run this job in the background. This will actually enforce the change, and I want to make one more point about where the enterprise product's gone recently, and that's this event view. So now this is actually populating with data like it was a moment ago, and it's showing me I can view infrastructure with pending change, with failed change, and in a moment here it's going to start populating with actual change. So I can see it going through individually making changes, and I can go back, I can refresh this view on the web UI and start viewing the machines that are changing, drill into one of them, and inspect the individual changes, and sort of have that feedback loop from I started this in version control, I knew what the value was, now it's present, and if I went back to add Michael again to this list, I could see the difference between Michael not being there and Michael being there. And for us, it's really just, we've always cared about these problems, and they've really been that whole life cycle of problems. Store your infrastructure as code, make change to that confidently, and then give you a lot of tools for understanding how that change is being made, be able to make that change more interactively, and we're just now, with the change to Puppet, able to execute on those ideas a little more quickly.
Yep. Here's a new question that just popped in too, and then I guess we'll probably be up near the top of the hour. What about support for artifacts, repos, for instance, Nexus? Is this and I think I know the answer to this, but is this integration possible in Puppet?
Nexus being, is that the application artifact repository?
Yeah, it's the old Eclipse Java, and it's now run by Sonatype and Nexus, and a lot of open source and stuff like that, components. Familiar?
Yeah, I'm familiar with that. And from Puppet's perspective, wherever you store your artifacts, it's just Puppet knows how to go and retrieve that. And that's either Puppet code that you write yourself, which is a few lines of where to go get the artifact and bring it down, or you'll commonly see, and I'm sure there's one out for Nexus because it's pretty popular, on our Puppet Forge, where I had retrieved those two configurations early in the demo. People have already written the Puppet resources that understand, okay, where do I go and get this artifact? I expect an artifact, say it's a jar. I know how to install that jar into, say, Glassfish or Tomcat. And so all those kind of patterns exist already, and so for our integration, it's just a matter of what's your artifact server, we'll go get the bits, we'll put them down, we'll take whatever steps are necessary to deploy that application into its server, and that's all just part of the same tool chain.
Okay. I will just chime in here if you don't mind, guys. I work pretty closely with the Sonatype Nexus team on a lot of projects that, especially in the security world, which is where I spent 15 years of my life, and I know they talk about working with Puppet all the time, so I'm positive there is integration there, and I know several of the events I've done with the Nexus team, they've actually had Puppet folks. You know what? Gareth Rushgrove is speaking in our London event in June at InfoSec Europe about this, actually. So, okay. Might be, if you're in London, you might want to go there. Next, how does Puppet work with a CI tool like Jenkins? Another good question. Anybody?
That is a good question. Yeah, sorry, I was just ping-ponging back with Michael here. So I wish I had more time to demonstrate that today, and there's two ways that comes up. Either you're asserting an application change, and you want that change to go through a Jenkins test and build process, and then at the end of that process, commonly what our customers want to do is successful tests and successful builds means go ahead and deploy that, at least to a subset of the infrastructure, or if not production. And so what you can do is drive everything that I showed you today via our APIs. So that's the APIs for making those groups to segregate your infrastructure, the APIs for assigning work to machines, and it's the APIs for the command line experience I just showed you to actually enforce a change on infrastructure using Puppet. So commonly what people will do in their Jenkins workflow is add a builder step at the end to make remote calls to those APIs to deploy interactively. The other side of Jenkins for us that is used really extensively in our community and certainly in-house is for module testing. So anytime you assert a change to a particular bit of Puppet code, you can run that through a battery of tests, much like you do for your application. And then that would be part of the GitHub review workflow that I demonstrated. Jenkins would test that module, and you wouldn't merge it until that test passed.
Excellent. One other question. We still have 2 minutes, guys. I'm going to make the best use of our time we can. Does the new PE Puppet console allow you to run manual ad hoc runs like you demonstrated from the command line?
Yes. On every individual node, you can click a Run Puppet button and give it certain characteristics like no op or and so on.
Fantastic. Yeah, I think that as well. Well, guys, I think that's going to run us up right against the top of the hour here, and I hate to make people, well, people don't like to stay on. It was up to me, I'd stay on all day, but everyone has other jobs to do. That being said, though, thanks, Puppet guys, for a great, Michael and Ryan, thank you for a great, great webinar. Thank you to Puppet for sponsoring today. I'm sure our audience really ate this up. It's something that's in high demand, and I should mention that last week the Puppet DevOps Survey 2016 closed, and I know we'll all be waiting to see results from that, as it's always, it kind of sets the industry on its ear about where we are and where we're heading. So we'll all be looking for that, and maybe Michael and Ryan, we can have you back on at some point, or some other folks from Puppet to discuss it.
Sure, that would be great. Thank you, Alan, for hosting us, and thanks everyone for making time out of your day to be with us. We appreciate it.
Okay, well, that'll wrap up this webinar from DevOps.com. Thank you all for joining, and we'll see you soon in a new webinar. And have a great day, everyone.